Okay, cool. Well, thanks guys for coming to our workshop today on what is data science. Oh, I scroll down. So my name is Er Li, and I am a senior consultant and data scientist at IBM. I work on a lot of analytics, data science, and business transformation projects, mostly with our federal clients as well as private businesses. I studied economics and math and Chinese at Dartmouth. And in my free time, I really like baking, make a mean banana bread, and I run marathons. And I'm originally from Maine. I came back to Maine for the pandemic, so I love exploring my home state. So today's talk is going to be kind of giving all of you guys a foundation and just a brief kind of high-level introduction on data science. So what is data science? So data science is a multidisciplinary field where we're trying to gather kind of insights, try to find missing patterns and look at predictions for the future from data using a combination of math and statistics, programming skills, and domain expertise in order to try and solve real world problems. So, you know, there's data science is, I think it's such a buzzword these days, and you hear a lot of like data science, a lot of buzzwords relating to AI, just artificial intelligence, machine learning. And so I kind of want to kind of break each of those down a little bit. So kind of the bigger bubble here is like artificial intelligence. It's basically a computer science field where we're trying to impart human intelligence onto machines and teaching machines how to think and act and see like humans do. And part of, you know, a subset of AI is machine learning, where we're basically trying to teach machines or how to kind of learn by ingesting data and then driving insights and then letting them learn on their own, so that when we feed machines more data, they are able to kind of continue learning and getting better at decision making. And a lot of this has to do with, you know, statistical models, a lot of machine learning algorithms, and we let kind of machines improve. So I want to give you a little bit of an idea of what the data science process from kind of start to finish. So, you know, usually on a data science project or when you're starting your own project, you start with kind of asking an interesting question. So, you know, what is your goal? What do you want to get from, you know, the data that you might already have on hand, or what question are you trying to answer? Or, you know, what do you want to predict? You know, it's kind of a hypothesis, so to speak, you know, when you're in a science class, right? And you're trying to formulate hypothesis and then drive towards finding evidence or whatnot to kind of get an answer. And so it's the same thing here. You know, you start by asking an interesting question. And the next step is to get the data. So, you know, trying to find data sources, determining whether data is relevant or not, you know, figuring out whether the data you're getting is proprietary or whether, you know, it's open source. Kind of, this is like the whole kind of gathering your data part. And all of this kind of, you can notice on the screen, it's all the arrows, it's iterative. So, you know, you can jump back and forth depending on kind of what step you're at and if you're presented with new information, things like that. So after you've gathered your data, the next step is to explore the data. So usually we go and plot the data just to kind of see the initial pattern and see if there are any anomalies, any outliers, whether there's anything missing. So usually raw data is very messy, and I would say almost like 70% of the data scientist's job is to clean data. And so in this step, you know, you're visualizing and doing some initial data exploration, and also figuring out, if there's missing data, how do you patch that up? Do you try and just exclude anything that's missing, or just kind of throw it away, which usually you might not want to do, or try to kind of patch it up through like data imputation, things like that. And so once you have your data all cleaned and processed, then the next step is to model your data. So this is where kind of the machine learning comes in, where you're utilizing a variety of models depending on what data you're looking at and what problem you're trying to solve, to try and kind of use these models to fit your data and or take the data and fit your model, and then try to drive towards kind of some answers. Again, iterative as well. So you can be modeling your data and then get more data, right? And then so you would go back to the explore the data step, or you might come to this step and you realize, oh, I kind of want to reformulate my question. You can always do that as well, right? So all of these arrows kind of jumping back and forth. It's very iterative. So once you kind of fit the model and have several models on hand and you validate it, and then you decide kind of which model is the best for your use case, the next step would be to communicate and visualize your results. So in this step, it's really important to be able to communicate kind of what you did, why you did it, and the results that you've obtained, and also visualize it. So using a variety of data visualization to kind of show your results in a visual way. And I like to think of data science as interdisciplinary in that you're using a variety of skills and incorporating it all together. But I think one of the more important ones is actually to be able to communicate and visualize everything that you've done, because you can be a fantastic data scientist and kind of try and find all these different insights, and they're all so interesting, but if you're not able to explain it to a general audience, then it's kind of all for naught. So so communicating, visualizing, and then in a professional setting, deploying your models into the real world, those would be kind of that last step. But again, it's all very iterative, and kind of where you are in the process. If you're presented with new information, you kind of you're able to kind of incorporate that. So next is what is the data science kind of skill set? So like I said, data science is multidisciplinary. And so there's a bunch of different kind of groups of skills that kind of make up data scientists. So I'll start with kind of hacking skills. So that's kind of incorporating your computer science knowledge, which is necessary to kind of clean the data and manipulate it. It's also acquiring data as well. Sometimes you have to go online and scrape data or try to download data, things like that. So that's all incorporated into this hacking section. The next is obviously math and statistics is super important to have a working knowledge of a working foundation of math and statistics skills, because how you kind of analyze the data and model it is dependent on your knowledge of math and stats. And then the third is having what I referred before as domain expertise. So having kind of a background in the area that you're trying to research or trying to use your data science skills in to answer the questions. For example, if you are, I don't know, maybe a biologist, right? Or even now these days with the pandemic, you study like epidemics or pandemics, and you're an epidemiologist, right? Having a background in that area, knowing what data is available to use, knowing the kind of the math and stats that are relevant to your question, that's kind of makes up this expertise area. And so a good data scientist will have elements of all three areas combined, and not just kind of one or two of the areas. I think that danger zone here that they're referring to is, you have the hacking skills, you have expertise, but if you don't have a good understanding of math and statistics, kind of, you don't kind of have these methods that you're following that might be incorrect, and that could get you to like an incorrect analysis. So that's kind of, again, this interdisciplinary combination of all three kind of areas is what makes up data scientists, or data science, and what a data scientist needs to know. So next, I'm going to give you a little bit of an idea of like the data science toolbox. By no means do you have to know every single thing on this list, but having a foundation knowledge and kind of building on that is really important. So, I mean, for me personally, I didn't study data science. I kind of worked my way into this area kind of at work. And so I'm still relatively new to data science as well. And what I've learned is that, it's good to have a foundation in math and stats and domain knowledge, and at least have, one language that you can program in that you're comfortable with, and then be able to communicate and visualize. And those kind of are the bases that you can build upon. So over kind of in the math and statistics realm, having a knowledge of the different models that are out there and what the best use cases for them are, in machine learning, is important, and then knowing the difference kind of between the supervised learning versus unsupervised versus optimization versus reinforced learning. Those are kind of the basis for your math and stats kind of requirement. Next, the hacking skills, right? So having computer science fundamentals, being comfortable with at least one scripting language, such as Python, or you can use R. Knowing kind of how to query data using SQL. Those are kind of your basic skills that you might you would need to have kind of to start kind of doing data science. On this list, you can also see Hadoop and Hive. Those are kind of big data platforms. And then AWS is a cloud service that a lot of people use, a lot of businesses use to store their data. Next is domain knowledge. So like I said, having a little bit of understanding of the area that you're trying to answer questions in, passionate about, that area, curiosity about the data, problems, and being innovative and creative. That's all kind of part of the soft skills and domain knowledge. And then lastly, but definitely not least, is the communication and visualization. So being able to kind of communicate your results and what you're doing, why you're doing it, and translating that into insights that drive decision making, as well as being able to tell a story and convince your audience. Those are really important skills to have, as well as visualization. Presenting your results in a way that for others to understand that might not have the expertise that you have. So all four of these areas are really important. Again, by no means do you need to know everything to be a data scientist. It's all about starting with a foundation and building up. So next, I kind of want to talk a little bit about, data science in the real world. So you can throw in the chat if you like different maybe examples of data science that you see in your day-to-day life. And I'm a big fan of corgis. I love dogs. So maybe these will give you some inspiration into, what are some real life use cases of data science. And then I can go ahead and let me see if I can see the chat. Can you guys still hear me? Yep, internet search. So yep, like a Google or Yahoo type of thing. Supply demand for a product. Yes, yep, definitely. Looking at user data, right, or, from your buyers to see maybe what next you like to buy, or what to keep in stock. Customer service, definitely, like a chat bot, for example. Social media, definitely. Ads, yep, targeting ads to to different consumers depending on their user history or your Amazon history. Yep, so definitely looks like you guys are ahead of the curve here. So let's talk a little bit more about a couple of use cases. So living in Maine, right, there's a lot of different weather patterns, aka snow in the winter, they have to be worried about. So, you know, before I go to bed at night, usually ask Alexa, what's the weather tomorrow? And that's actually incorporating two different types of applications of data science. So the first is natural language processing. So when you're asking Alexa, you know, what's the weather, or what's the traffic, or things like that, they're actually, Alexa is actually taking what you're saying, analyzing kind of the sound to make sense of the question you're asking, and then rerouting back to you an answer that makes sense. So that has to do with natural language processing. It's turning the language that you're using into something that they can understand, Alexa can understand, and then reroute back an answer that makes sense. And, you know, I think years and years ago, before we had a weatherman, you know, you would not really know what the weather would be like tomorrow. But nowadays, the amount of data we can collect on weather, you know, precipitation, you know, wind patterns, things like that, that can all contribute into a weather model that's able to predict kind of, you know, the path of a hurricane, or whether it's going to rain tomorrow, things like that. So actually a very simple question of Alexa, what's the weather tomorrow, actually incorporates a lot of data science in the background. So next, I don't know if you guys have seen any self-driving cars out there, but autonomous vehicles are another use of data science, where because they're loaded with data sensors that kind of send information to an onboard computer, which processes the data and then gives the car instructions on kind of how to steer, how to brake, or when to steer, when to brake, when to accelerate, and you know, act like a human being, right? So, so you know, think about when we talked about AI, just teaching machines how to think like humans. And if, you know, this is a classic example of that, but you're also taking in a ton of data and trying to drive insights from that data. So a very classic example of data science is the spam or ham. So classification is the process of categorizing data into different classes or groups. And that's exactly what your email system does, is it takes your emails and it does a little bit of, you know, like language processing, so text analysis, to kind of determine whether a message is ham, just like for real, you know, a message for you, or spam, just spam message. So email filters will be able to classify each email based off of the content of the email and kind of reroute the messages into the proper folder. And next, so somebody mentioned social media. So recommender systems are another form of a use case of data science, where it is able to suggest products, services, and information by analyzing user data, which is, you know, your previous activity, as well as the activities of other similar users. So for example, for Netflix, you can always see kind of, I think they give you a percentage, you know, 90% of people who watch this, like, you know, prefer this movie or that movie or this TV show. So they're able to use kind of user history, your own user history, as well as other users who they think are similar to you, to recommend new TV shows and movies that you would like. So, you know, that's another reason why TikTok is so addicting, is because it just constantly feeds you content that they're able to kind of gauge, you know, what videos you like, what areas, and then keep feeding those contents so that, you know, you just can't get it off the platform. Same thing with Spotify. I get a Spotify playlist, I think every Friday, that has just like, you know, new music that you might enjoy. And that's based off of my listening history. So based off of the kind of music that I like, you know, kind of suggest new music that that I might not know of that I might like. And of course, Amazon, especially with the holiday season, you're probably buying a ton of presents. And if you notice on the bottom of the page, they'll kind of, you know, give you like, you might like this, right? Or you might enjoy this, or other buyers who bought this item that you're looking at also bought XYZ other items. So this is all kind of incorporated into a recommender system, these algorithms that are able to analyze the data that you provide and kind of suggest new content for you. Another use case of data science is fraud detection. So, with the holiday coming up and a lot of people using their credit cards, there might be cases of fraud out there. So banks and credit card companies use anomaly detection algorithms to detect potential cases of fraud in order to protect the customer as well as prevent monetary loss. And again, this is using algorithms to kind of detect suspicious activity and kind of pinpoint that and make sure that, folks are protected from getting their information kind of used fraudulently. But those are just kind of some of the, examples that we see day to day. There are a ton more use cases out there. We talked about prediction, classification, recommendation, but when you go and get your credit card score, credit card scoring companies, use kind of ranking systems. Someone mentioned in the chat about ads, so segmentation. They're able to kind of, take data on different customers, segment them into different areas, and then target advertisements specifically for certain groups of consumers. Forecasts. I think this is more not about weather, but talking more about like sale and revenue. So kind of predicting, what is my business, what are the sales and revenue numbers going to look like next year, based off of how I've performed this year or this quarter. So plenty more use cases out there that you can definitely pick up, if you're during your day-to-day life. So if you're interested in learning more, I've included a couple of resources. There are a ton of resources on the internet, but here's just some that I've found that might be helpful. So there's an article called "What is Data Science?" This gives you a very good overview and foundation of, what data science is, what are the steps, what kind of projects are out there that you yourself can kind of play around with to learn more about data science. Khan Academy has a nice computer science video series. I think this is skills portion of the data science Venn diagram. Kaggle is a website where basically they host competitions and where you can go and they will provide the data and provide kind of a problem statement. And then you can go ahead and try to develop an algorithm to solve the problem at hand. And you have a lot of people participating in these competitions, and they'll, post their code and their progress. And so it's a good learning experience, especially if you're kind of new and never done like a beginning to end data science project. And finally, the ultimate data science learning list. Some guy kind of compiled a lot of these free learning resources, and you can check that out to see what kind of resources you might want to start off with in terms of online classes and things like that. And then the tools that you might want to download. So I use Anaconda, which is a platform. You download it on your computer and you open it up, and it just gives you a ton of options of, different platforms to start programming. I like to use Jupyter Notebook because it's just kind of like a notebook where you can take notes, you can write your code, and you can kind of edit step by step. And then I found this YouTube video where it's kind of an intro to data analysis using Python, which is one of the more popular languages. And it's a full course for beginners, and they'll walk you through the different packages that a lot of data scientists use that are kind of pre-written, and you just have to download and start using along with your data. And that's about it. So thanks for coming to my talk, and I'm happy to take any questions that you guys might have.
I have a question.
Sure.
So what would be like the hardest part, or like the part you like least about like data science?
So the hardest part it's definitely that data cleansing, data manipulation part right before the modeling, because that takes the most time, and it's also the most kind of heavy lifting on your part, just because, you know, when you have a lot of raw data, it takes a lot of work to get it into a format that you can use. So I'm saying, like, you know, a lot of missing values are a common situation. You know, a lot of, you know, sometimes I've seen data points where it's like, well, like the one that actually, the data file that I'm working on right now, it's just like a lot of duplicate values with a ton of rows that you have to like try to clean and get rid of all the missing values that you might not need. You might want to impute values, so fill in anything that's missing with a value that you generate yourself, because the worst thing about putting data into a model is, and having it not work, is because your data is so messy. So that part takes the longest, takes a lot of time, a fair bit of creativity, to kind of get your data from its raw form into a version that can actually be used in a model.
Okay, thank you.
Yep. Anything else?
Yeah, if anyone else has any questions, then you can unmute or just throw it in the chat.
Mm-hmm.
I had a question.
Sure, go ahead.
So you mentioned like you can use data science for like showing relevant ads and like persuading people to click on the product. So how can you like the data that they collect to show those ads, how can they say like that data is not privacy, like it doesn't infringe on privacy rights?
Yeah, so that's a good question. And I'll be honest, I'm not like the expert on this, because that's not an area that I've worked in. But I think when you use, say, Amazon or any social media, they'll have, I think there'll be like a, what is it? You know how when you click through, when you log into something, and they'll have their like terms and statements, and then you just say yes. So a lot of that might be included, where you give people permission, or, you know, give the platform permission to use your user history in order to kind of gather information. So there's like a reason why Facebook is free, right? They take the information that you give them, and then they're able to target ads to you, and because they make their money through ads. Another thing is, a lot of this I think is anonymized. So your name might not be attached with it, but your user pattern might be used. So, you know, I might not know that it's actually like you. I don't know how to say your name. Is it Sahithi? Yeah, but, you know, they'll know kind of, you know, that you bought, you know, a cute Pusheen stuffy, and then they'll start giving you ads on other different stuffed animals, right? So some of these are anonymized to kind of protect privacy, but in terms of other user privacies, I don't have a great answer on how they kind of protect that, but I can get back to you. I just need to do more research, because it's not an area that I'm totally familiar in. But let me get back to you on Slack with that, okay?
Oh, thank you.
Yep. Let me just get your name down so I can know who to Slack with more info. But anything else?
If there are no other questions, then I think we can wrap up for today. Thank you so much for giving us this comprehensive overview of what data science is. Like, it was really, really interesting, and I loved all the little info, like graphics and like the GIFs. But it was really amazing.
Thank you. Yeah, I love GIFs myself, so I figure, you know, a lot of presentations are really boring. I wanted to make sure it's at least a little bit more lively to keep your attention.
Thank you so much.
Of course.
Yeah, and definitely if anyone joined in a little late, I'll send out the recording this week. And
Okay.
if you have any other questions for Early or either of us, you can just send a message in the Slack, definitely.
Yep.
So
yeah, just send me a Slack message. If you have any other questions, Cynthia, I'll get back to you on more info on the user privacy for ads. And yeah, just let me know. I'm happy to help with anything or connect you with resources if I don't know the particular answer. Just let me know.
Okay, awesome. Everyone have a wonderful day, and we'll see you at our next event.
Bye, guys. Have a good rest of your Sunday.